Good evening, Luzon, Visayas, Mindanao. Today, we are going to discuss about neuromuscular junction, its components, importance, and how does NMJ reacts in a process.
What is neuromuscular junction? Neuromuscular junction, or NMJ, is a highly specialized synapse between a motor neuron terminal and its muscle fiber that are responsible for converting electrical impulses generated by the motor neuron into electrical activity into the muscle fibers. What is the function of neuromuscular junction? Neuromuscular junction, or the new neural junction, it is the site for the transmission of action potential from nerves to the muscle. It is also a site for many diseases and a site of action for many pharmacological drugs. What are the components of neuromuscular junction? For convenience and understanding, the structure of NMJ can be divided into three main parts: a presynaptic part, or the nerve terminal, the postsynaptic part, or the motor end plate, and an area between the nerve terminal and motor end plate, or the synaptic cleft. Luis Evan Ibanez, reporting.
Why neuromuscular junction is important. Neuromuscular junction is a microstructure present of the junction of motor neurons and the skeletal muscle fibers. It acts as a bridge connecting the skeletal system and the nervous system. The anatomy of a neuromuscular junction can be divided into three parts: the presynaptic terminal, the synaptic cleft, the postsynaptic membranes.
And now, what is the structure and the action of neuromuscular junction, or NMJ? First, draw the brief diagram of neuromuscular junction to understand its structure. So, as you can see, this is the axon of the motor neuron. This is the axon terminal. This is the presynaptic membrane, and these are the various vesicles, which contain the acetylcholine that is the neurotransmitter involved in action. This is the voltage-related calcium channels. And this is the synaptic cleft. This is the postsynaptic membrane, also known as sarcolemma. These three structures together form the synapse. Now, this ion channel you see on the postsynaptic cleft, these are the acetylcholine receptors, which are basically the voltage-gated sodium channels. So, this is just a brief description about the structure. Let's see how the neuromuscular junction acts. It all starts when the action potential reaches the axon terminal. Now, this action potential first acts upon the calcium channels since there are voltage gated. These open up and they cause the influx of the calcium into the axon terminal. After this influx, the calcium basically activates a group of proteins known as the snare proteins, which involve proteins like synaptic brevin and syntaxin. And these proteins, when activated, they attach to the membrane of the synaptic vesicle and cause the exocytosis of these vesicles. Fuse with the presynaptic membrane, and they cause the release of the acetylcholine into the synaptic cleft. The next step in the transmission is the action of the acetylcholine on receptors. Since these are sodium channels, these open up and cause an influx of sodium ions into muscle fiber. Since sodium is a positive ion, it causes the generation of the action potential in the muscle fiber, which in turn leads to either muscular contraction or it may also lead to the increase in the tone of the muscles. So after the acetylcholine has acted on the muscle, the enzyme acetylcholinesterase which is also present in the synaptic cleft. It acts upon the axis of the acetylcholine and it degrades the acetylcholine. So that no more further than the action of the acetylcholine on the acetylcholine receptors take place. This was a brief description about the structure and the action of the neuromuscular junction. John Dave Madrid, report.